So, today, what are we gonna talk about, little Oscar?
Blend shapes.
Exactly! Whee! But not with you, you are not really talkative. Today, we're gonna talk about blend shape or morph target in Unreal, and I'm gonna show you all the little subtleties that you may wanna know. The workflow here starts by using Blender to Unreal, what to export and import in Unreal, and all the setup in Control Rig. Follow me, it's here right now. Alright, today's stars is of course Scooby-Doo. Set up to showcase some of his signature expressions, which he pulls off like no one else. The setup is quick in Blender using shape keys. While this could be done in other DCC like Maya, the process in Blender involves just a few shapes to create expression, and it's easily manageable alongside drone animation. There's no need for any extra export setup in Blender, but be sure to avoid using the same name for shape keys across different meshes, as this can lead to morph target overrides in Unreal. All shape keys will be merged into one single asset. In Unreal, you don't need to do anything special during imports, as the import morph target option is enabled by default in the new importer. Now that Scooby is in, after assigning his material, we're ready to proceed. Before setting up anything in the Control Rig assets, make sure to first go into the skeletal assets and perform a crucial step. But before, the first thing to do is verify that all your blend shapes or morph targets, as they're called in Unreal of course, have been imported correctly without issues. As you can see, you can also import additional morph targets afterwards in a non-destructive way, which is important. The key part is in the Curves tab. By default, none of the morph targets are converted into curves when importing your skeletal mesh. This step might seem complex, but it's essential because in the Control Rig asset, we'll be managing these curves in the graph later on. Without the correct mapping, setting up Control Rig curves won't be possible. So how to handle that? Here's a manual solution. While I don't currently have a script to batch import or create everything at once, a Python script would definitely help here. One method is to manually add curves by clicking the button or right-clicking here. Then simply enter the exact name of each morph target as seen in the previewer. You can copy-paste names to ease the process. Repeat this for each morph target. Before going any further, you need to pay attention to the type of curves you want to create. There are two options, morph target and material. The one we'll be using is the morph target here, as it manages vertex positions via the curves. The other option, material, lets you drive material's parameters directly, such as controlling things like normal wrinkle maps or the pupils in the eyes. Now that the first part is complete, let's move on to the Control Rig asset. I've already set up a simple forward solve for Scooby to play around with and to demonstrate that, of course, the morph target setup can be applied to any type of Control Rig. In the Control Rig asset, make sure to import the curves you created earlier into the Curve Container tab. By right-clicking and selecting the Import from Mesh feature, you can easily retrieve all the curves from your skeletal mesh. I want to emphasize that this process has changed slightly, but we could automate the entire workflow in the future. We may even have a more streamlined process in the upcoming release. Now the last step is to create the logic for all the curves in the graph. For now, let's stick with the forward solve, though we could also explore the backward solve. There are two options here. Let me show you the first and simpler one. Start by creating a new control to nest the curve controls into. We name it Curves, and don't forget that it must be a visible control. Inside this, create another control, but make it an animation channel with a float value type. By doing so, you'll have direct control via this animation channel, without needing to set up a visual control. This might be less intuitive, but it's a more direct approach and can be really useful when you don't want to deal with the complex setup. Let's call this new control C_smile. Now for the graph setup, drag and drop the curve animation channel control and pick the getter form. Then right-click and select the Set Curve Value node. Next, define the curve you want to adjust, in this case the smile curve, and after that you can connect everything just like a regular control bone setup. Sometimes the setup can feel a bit aggressive and hard to control. To make it smoother and more intuitive, you can add a divide node with a B factor set to 100 for example. You should also consider the min and max value of the animation channel itself, which you can adjust here. This is important because it allows you to fine-tune the morph target. For instance, you can slightly override the value to get the exact result you want by setting a negative value for the minimum. The simpler way to adjust everything here is directly through the animation channel. With the same setup, you can add another curve value node and specify additional curves to trigger and adjust them at the same time via a single control. This is particularly useful when creating complete expressions like I do here for the smile expression. You can test everything in a sequencer as well, and you have a robust and efficient way to control one expression via the corresponding track. Another way to manage and control curves is by adding a float control directly, which gives you a visual cue while animating in the scene. With the previous solution, we were managing the value through the track and the details panel, but this method allows you to directly interact with the control in the viewports. To start, let's create a basic Euler transform control and move it to the corresponding spot. Once it's in place, be sure to save the new position by right-clicking and selecting Set Offset Transform from Current. Then, change the control to a float control only now. Otherwise, you won't be able to adjust its position unless it's parented to another Euler control. Now we have a debug line showing the min and max value of the float control. Adjust the axes and values accordingly to match the behavior you want. This here is the setup I am aiming for. Next, grab the control and drag it into the graph as a getter form, then add the setCurveValue node, just like we did with the previous solution. After connecting everything, you can now manipulate the morph targets, but we still need some adjustments, right? There are several ways to tweak this. First, for example, you can add a CloneValue node to redefine and override the initial min and max values of the control. Sometimes we want the visual debug line of the min and max to be larger than the actual min and max of the curve, so we can easily play with the value. Finally, I want the slider behavior to be the other way around for better logical flow. To easily invert the values, you can add a multiply node and set the B factor to -1. This will reverse the behavior, making it more intuitive and giving you better control. Now you have a nice and effective control in place. In Sequencer, it will work as expected, but you notice something quickly that needs to be corrected, right? With this setup we have, the control is currently not attached to anything, meaning it will stay in place regardless of the animation. Let's fix that in a simple way. Back in the graph, we can create a null and place the float control inside. It's better to parent something else rather than the control itself, as parenting the control directly could cause issues or create unexpected behavior. After the first part of the FK-solve logic, add a parent constraint node and specify the null as a child and a neck control as the parent, for example. Now everything moves as intended, the setup is correct, and everything is following properly. This way, your control will stay connected and you can build your animation in the sequencer with ease and in context. Whether using the animation channel or the float control, you now have the complete workflow for importing and setting up morph targets in Unreal Engine 5.5. And that's all for today, guys. I hope you enjoyed the video. I'm probably gonna make other videos on the subject because there's tons of things to talk about. Thanks for watching and see you next week for a new one. Bye.